Hi, I'm Matthew Schwartz with iSMG. It's my pleasure to welcome to the iSMG studio Jeremy Katz, Vice President for Code Security at Sonar. Jeremy, great to have you here today.
Thanks for having me.
We're going to be talking about scaling trust, how to maintain quality and security in the age of AI-driven velocity, which is a little bit of a mouthful, but it's going to come down to how we code better, code more securely in the age of AI. Fascinating topic, so much nuance. So let's jump in with continuous integration systems. Why are they not designed to handle the changes that we see being driven by AI agents?
I mean, Matt, when we look at it, CI's only been a thing really for about 15 years. Before that, people would run tests once a day. And then as we moved to cloud, people started, oh, we need to deploy faster. Continuous integration grew out of that. And now what we're seeing is, oh, the growth of changes, the velocity of changes is just accelerating. And we can't wait until like the last minute to run the test. We really need to sort of add the sort of quality and security points in the inner loop of the agent's development, because otherwise it's too late. A good example, very much on people's minds this week, especially malicious packages. If you think about some package in your supply chain getting hacked, getting compromised in some way, well, if we wait until CI, it's already too late. We need to be checking that at the time that the agents are starting to pull it in. And this is actually true with humans too. It's just the volume is so much greater. But I mean, like I said, we've literally seen this twice in the past 7 days of a new sort of exploited thing.
I know, during the RSAC conference, and it wasn't like we weren't already seeing it before. It just keeps coming up.
It's just accelerating. Yeah. It's just accelerating. And so we've got to like really think about how do we put a lot of the checks that we would traditionally do in CI. We still need to do them in CI. Let's belt and suspenders this, but let's do them earlier. Let's do it in the loop so that we don't install these malicious packages, so we don't leak secrets or anything like that. Because once those are out of the bag, like, well, now you're talking to your CISO and you're starting an incident response and everybody's having a bad day or night.
Yeah, oh, for sure. So with continuous integration, things obviously got faster. I mean, the speed with which things are happening now would give me nightmares if I was a developer, which I'm not. But at what points, I mean, are we talking about basically validating the code every time it's written? Or, where do you begin to think about, trying to bring this integrity?
I mean, to me, it's really as it's being written. It's not even after it's been written. So I'm actually really excited about this stuff. Like, I'm actually having more fun and creating more code, though not like typing out like lines of code myself, but I'm creating more code than I've created probably in years, because I've spent my time managing teams, but now I can also manage some teams of agents and create some code on the side, which is a lot of fun. And it really is, as the agent is sort of initially creating the code, it needs to do like, wait, let's check this against some deterministic rules. Let's make sure that this fits the security profiles we need. And, that's really good news for sort of Sonar. That really works well for us. As sort of our big thing is we provide those sort of deterministic rules, and we've been doing it for a long time. And so now we can do that as agents are building things and sort of really injecting those gates super early. And so it really is this like, we call it the inner loop. You basically you can think about like, you tell the agent, I want you to add this feature, this widget, whatever on the website for checkout. Well, let's make sure that as the code is iterating it, if you've ever watched Claude Code generate something, it's just like, oh, I'm going to do this now. I'm going to do this now. And having it do I'm going to do this, and now I'm going to make sure it's secure is actually really pretty important.
It will be fascinating to me if, having strived for so long to get more secure code development practices into the CI pipeline, or CI practices, if AI is the thing that is finally the forcing function, because there's a lot of concern obviously with AI about what it's going to do if you don't keep track. But if you do keep track, there's a real opportunity.
There's a huge opportunity. And I mean, if we think about the amount of things that we do, how many security trainings, I mean, even non-developers, how many security trainings do you go through to be like, oh, don't click the link in the email?
Exactly. Think twice.
To take it to the thing that isn't writing code. And these are the sorts of things that oh wait, we also have to worry about our agents doing this. We have to worry about it in sort of coding practices. But the nice thing is also, it's much easier to be like, here's the set of rules you have to follow, and have the computer do that, have a it's much easier for a human to forget to follow the rules.
Oh, yes.
So
yes.
there's
all have
actually a
bad
lot
days.
of we all have bad days. All of us. But yeah, so that's why to me it's a lot of fun. Is it really is this like it's an opportunity, and it's exciting. It's so exciting.
Now, are some of the organizations that you talk to about how to improve their practices, are some of them still attempting to do this sort of thing manually?
Yes.
Okay.
Like
That seems
there's
like
no,
a challenge.
well, it turns out, you can, if you do code review by 3 different humans, you're going to get 3 different sets of comments. You're going to get 3 different things that are getting caught. And that's in some ways good because more eyes, you're going to see more things, but it's less good for these sorts of things that you always want to hit. It's less good for these sort of deterministic rules that you always want to catch. And so this all translates over. Like the thing that I'm realizing is that it really is an evolution where it's just like, oh, this is another set of, if you think about like, okay, the AI wrote the code. Now we can have a couple of agents review it. We can have some deterministic rules that are applied on top of it. And then we can have a human look at it. Well, we've just like multiplied the number of people who have looked at this thing. We've multiplied the number of checks and balances we have on things being done properly. And I think it's actually going to increase quality in the long run. It's going to be an interesting.
There'll be an evolution perhaps in learning to work with the new tools, but that's not necessarily, like you say, more eyes on is not necessarily a bad approach.
And this is the life of computing.
Yeah.
I mean,
Things change.
I've been in this for more years than we should talk about.
Well, which is good because you're bringing in some perspective, which I really appreciate. Well, one of the things I want to make sure we touch on, you talked about malicious packages sometimes getting used. Now, AI generated code, we know that if it wants something, it'll sometimes make it up. And we know that attackers will sometimes know that and they'll provide the thing that it's just hallucinated. So what are some of the vulnerabilities that you're worried about, or maybe like the introduction of malicious dependencies, perhaps? What do you need to be aware of with that risk?
Yeah, I mean, that's one of the big ones, especially because it's so easy right now to just publish a malicious package and I mean, I feel like this really started, I was talking to somebody on the show floor this week. I feel like this really started with crypto miners. Like that was some of the first malicious open source libraries we saw were these malicious packages that you installed them and it basically ran a crypto miner in the background. Well,
there was a financial incentive.
There was a financial incentive. So it gave the reason to exist. And so the success of that was like, oh wait, we could do more things, which started to lead to how do we exfiltrate data, secrets, etc. So it's very easy for somebody to publish one of those. The nice thing is there's increasing sets of resources out there to know about, oh, these are the bad things. And so basically, as long as you're integrated with a tool that can tell you, oh, wait, before I go install this package, let me make sure it's on my allow list, make sure it's on my safe list, make sure it's not on my bad list, because it's, you can kind of take both sides. You can either take the like only do the things that are allowed, or you can do the I'm going to have the things that are bad and just don't allow those. There are trade-offs between those. And as long as you have something like that in place, and that's part of the, these are the instructions for how to do something, then you're going to be safe and secure from sort of some of those sorts of attacks. And I do think those are kind of the most likely. That's kind of going to be the biggest class, especially
because they're easy to perpetrate.
They're so easy to perpetrate. They're pretty lucrative, it seems. I mean,
well, or if it's a spy agency or something, they could give you a huge reach. So, which is why it's such a concern.
Yeah, the nation states are absolutely a concern there.
All over this, yeah. Well, I want to make sure we talk about guardrails, verification, technical debt, security debt. How does this help?
So, I mean, I think we're going to see some of that changing. So historically, Sonar's really looked at code quality and code maintainability in addition to security. And code quality is changing. It's less about can a human read the code. It's more about is it structured in a way that it's efficient for agents to understand the code base and work well within the code base in an efficient way, because we don't want to just burn tokens needlessly. And so we can think about structuring code differently. We can think about giving insight to the agents about the structure of the code. We can, if you have the idea that like, oh, these are the patterns we follow, this is where the various pieces of code live, it means that the agents don't have to go and read everything. They can be a lot more targeted, and that leads to greater efficiency. And efficiency means fewer tokens used. Fewer tokens used means it's cheaper. At the end of the day, what do we all want? Cheaper, better, faster. I think that's
without sacrificing anything.
Without sacrificing anything, is it? That triangle's fun.
Yeah.
But it is this. We're gonna see an acceleration. Like I said, this is the movement of the industry over time: is cheaper, better, faster. We get all of them, and yes, they are in tension naturally, and that's a good thing.
Yeah. So, I mean, the reduction on cost must be a huge, when you're talking with prospects, customers, I mean, that must be a huge angle here, given the cost of running LLMs.
Cost is a huge thing. Interestingly, I think security is the bigger thing. Like, it really is people are more worried right now about the security than the cost. I don't know why. I think in the long run, we do definitely have to worry about both, but I think there is some amount of everybody realizes they need to be doing this and they don't want to be left behind, and they realize you can optimize costs later. Like, optimization is a thing that you should do after you're successful.
I mean, that's a great point. Practice first and then...
Yeah, there's a great, to put on my computer science hat, which I rarely get to wear because it's not, most of the day you're writing code, it's not computer science. But Donald Knuth said, premature optimization is the root of all evil. That's a thing that gets said a lot. And it is this, we need to be prototyping quickly. We need to be building quickly. We need to see customer value. And then we can optimize. We can optimize the loop as we go, but let's make sure we understand it. Let's make sure we're building things that are secure, that are quality, and provide value at the end of the day.
So just get started, keep security in mind, do it in a way that's going to be adding greater reviews, eliminate some of that kind of subjective bias that you sometimes see in the code reviews, and that's where we go from here.
Yeah, and like I said, this is the great thing, is that adding determinism on top of LLMs, that combo is really powerful. It's really powerful to have this very structured. We know exactly these rules got hit. We know exactly these things were followed because, to your point, the LLM is otherwise just going to make something up. So it's good to have those guardrails, to have those deterministic rules, to know that you've done the right things.
Fantastic. Well, Jeremy, it is super fascinating to get to talk about where we are with all of this. It's wonderful to hear that we're bringing security more into the picture, and especially with the rise of AI written code being so prevalent.
Yeah, no, it's like I said, I am more excited about building software than I've been in a long time. I mean, it reminds me of the early days of cloud. It reminds me of .com. It's just, it is another one of these just kind of step functions in how we build software and build value for people.
Wonderful. Well, thank you for letting us tap into that energy. Yeah. And I really appreciate your time and your insights.
No, thank you. Thanks for your time too.
I have been speaking with Jeremy Katz, Vice President for Code Security at Sonar. I'm Matthew Schwartz with iSMG. Thank you for joining us.